Hello, Algebra Scholars. This is section 6.4, Addition and Subtraction with Unlike Denominators. Definitely one of the more challenging and involved sections that we'll study this year. Here are all of the steps that we're going to need for doing problems in this section. I would encourage you to write these down into your notes so that you have them as a reference as you're doing homework. Step 1, find the least common denominator. As a reminder, to do so you need to factor all of the denominators, and you need to treat monomials and binomials separately. Step 2 is to write equivalent fractions. Step 3, you're going to then add or subtract as indicated, which means, of course, that you keep the denominator and add the numerators or subtract the numerators. Step 4 is to simplify the numerator, and we're going to look at a bunch of different problems and what that means. Then you'll refactor the numerator if possible, and finally cancel any like factors. So let's try a problem. All right, here's our first example. All right, step 1 is to find the least common denominator. So here's one where we don't really need to do any factoring because the denominators are all monomials. So to go in our LCD, we need a 3, we need an x squared, and we need a y cubed. So now we're going to write equivalent fractions that have 3x squared y cubed as the denominator. So what we'll do is we will ask ourselves, how did we get from the original denominator to the LCD in this case? The answer is x. And if we multiply the bottom by x, well, then we need to multiply the top by x. In the second fraction, we multiplied by 3, and if we multiply the bottom by 3, we have to multiply the top by 3. So now we will immediately add or subtract. So we have negative 2x minus 18 over 3x squared y cubed. We will factor the top to negative 2 times x plus 9. Be careful with your plus sign there. Over 3x squared y cubed. There are no common factors to cancel, so that is our final answer. Okay, in our second example, the least common denominator is just the product of the two denominators. So once again, really no work to show there. Now we're going to write equivalent fractions that have the LCD as the denominator. Here we multiplied by x plus 4, and if we multiplied the bottom by x plus 4, we have to multiply the top by x plus 4. Here we multiplied by x minus 3, and if we multiplied the bottom by x minus 3, we have to multiply the top by x plus 3. So here's what we have. X times x plus 4 plus 12 times x minus 3 over the least common denominator. Now, be careful. You are not allowed to cancel here. Even though you have factors in the denominator, you have terms in the numerator, so you are not allowed to cancel. So if you go back to your notes, you will see that you need to simplify the numerator and then refactor it if possible. So in this case, simplifying the numerator means distributing. So x squared plus 4x plus 12x minus 36. Combine some like terms. X squared minus 8x minus 36. And then our notes, if you look at them, say refactor the numerator if possible. So let's see, can we factor this? Two numbers that multiply to negative 36 and add to negative 8. Let's see, negative 18 and 2, no. 3 and negative 12, nope. And negative 9 and 4, no. So actually, what we have here is our final answer. All right, algebra scholars, in this third and final example, We have to do some work to find the LCD. X squared plus 2x plus 1 factors into x plus 1 times x plus 1, or better yet, x plus 1 squared. Second trinomial factors into x plus 1 times x plus 4. So our least common denominator, we need an x plus 1 squared and we need an x plus 4. So we're first going to start, actually, we're not going to write our equivalent fractions just yet. Actually going to rewrite the original problem in factored form. This will make writing the equivalent fractions easier. Now I'm going to write in my LCDs. Alright, so how did I get from here to here? I clearly multiplied by x plus 4. And if I did it to the bottom, I've got to do it to the top. Here I clearly multiplied by x plus 1. And if I did it to the bottom, I have to do it to the top. I'm now going to add my fractions together, which gives me x squared plus 4x plus x plus 1. Or x squared plus 5x plus 1 over x plus 1 squared x plus 4. The top does not factor, so that is our final answer.